Okay, yesterday we started a new chapter referring to arithmetic sequence, and our focus for this chapter is just the arithmetic. We learn a second type of sequence when we get to the very last unit at the end of the year. That being said, let's recap. Arithmetic sequence is a pattern of, or a sequence of numbers in which there is a pattern that you're adding or subtracting by. Now, yesterday we focused on what we call the recursive formula. This is just, they give you the first term, they give you the common difference, and you have to find the next few terms in the sequence or the fifth or seventh term. Well, that's all well and good if they are just asking for the next few terms. But then you get to these problems where they're asking for the 100th term or the 79th term or the 1000th term. And you don't want to spend time making that entire table until you get to the 1000th. So this is where the explicit formula comes in handy. Now again, this is the hard part about it, is they don't give you the explicit formula on the star chart. So it's one of those where you have to just know how to set up yourself from memory or just being able to identify it once you see it. So let me break it down for you. It's a different setup, but it has the same kind of terminology. So A sub n is just referring to a number in the sequence. We don't know which number. D, we already know from yesterday, is what's referred to as the common difference. This is what you're adding or subtracting by. So please don't look at the difference as meaning it's always going to subtract. It could be addition. So common difference, parentheses, n minus 1, which just takes the previous term, and then add your first term. A sub 1 is referring to your first term. Now that's one way to set it up, but the most common way that we've seen it set up is it's just rearranged differently. They put the first term first and then add the n minus 1 times the common difference. So same setup, it's just arranged differently, okay? So don't spend too much time on the details. So I'm gonna spend more time on the way that they traditionally set it up, which is this one. Okay. So let me show you how this works. So number one, just like yesterday, we first have to make sure it is arithmetic. So make sure they're adding or subtracting by the same sequence. So if I look from 5 to 2, we're subtracting 3. From 2 to -1, we're subtracting 3 as well. So I know this is my common difference. That's what we're subtracting by each time, okay? I also know that 5 is my first term. Those are the only two pieces you need in order to set up the explicit formula. So here's how you set it up. A sub n equals my first term, which I know is 5, plus parentheses n minus 1 times my common difference, which we said is -3. So that's how you set it up. And that's part of it, is can you set it up? Can you identify the explicit formula? But then they're going to take it a step further where they want you to find the 100th or 10th term like that. So what I mean by that is they want to know what the 100th term is here. Well, this is where I use the n term right there. So what I'm going to do is substitute 100 in for n, okay? So if I rewrite it, it's 5 plus 100 minus 1 times -3. And then you just follow PEMDAS. So I do the parentheses. 100 minus 1 is 99. And times -3 plus 5. And then I do the multiplication. So 99 times -3. Oops. 99 times -3. And then add 5. So the 100th term, like if I were to lay out an entire table from going from first term all the way to the 100th term, I mean, it's a long table, I would essentially get to -292. That is the 100th term. So let's do that again. Number 2, they want the 79th term. So let's first figure out what the common difference is. From -9 to -3, we're adding 6. From -3 to 3, we're adding 6. From 3 to 9, we're adding 6. So the common difference is adding 6. Where the first term that's given is -9. Okay, now we just have to practice setting up the explicit formula. Again, we're going to set it up the same way. So A sub n equals the first term, which I know is -9, plus parentheses n minus 1, times the common difference, which is just +6. And you don't have to put +6 because it's just positive and it's being multiplied. Okay. Now, another way I could do this is just like distribute and simplify and then substitute the n value. So what I mean by that is let's distribute. 6 times n is 6n. 6 times -1 is -6. and then I add -9. When I combine like terms, I have 6n -9 plus -6 is -15. So that's a simplified version of what we do. We're going to focus on this tomorrow, but now they want to know what the 79th term is. So all you have to do there is plug in 79 in for n. So I could plug it in here and work it out like PEMDAS, or I can plug it in here and it's just a little quicker. So if I do 79 times 6 and then subtract 15, the 79th term would be 459. So either way you want to go about it, we'll do the next two just like that. So let's go back to the number 1. So number 3, our common difference, let's see what it is from -30 to -22 is adding 8. From -22 to -14 is also adding 8. From -14 to -6 is also adding 8. So be careful with negatives. So I know my common difference is +8. And my first term is -30. So if we set up the explicit formula, again, it's just a sub n equals the first term, which is -30, plus parentheses n minus 1. And then the common difference we said is +8. So if I treat it like I did number 1, instead of distributing and solving, we're going to just plug in the 43rd term for n. So if I rewrite it, it's 43 minus 1 in parentheses times 8. So now I just do PEMDAS. So 43 minus 1 is 42. 42 times 8 is 336. And then add -30, which is 306. So the 43rd term would be 306. Okay, let's do number 4 like we did number 2. And I'll go back and forth so that way it's pretty repetitive. If I look at number 4, this one has some decimals, so it does make you think a little bit. But to get from 2 to 5.5 is 3.5. From 5.5 to 9 is also 3.5. And from 9 to 12.5 is also 3.5. Okay, so I know my common difference is adding 3.5. I know my first term is 2. So if we set up the explicit formula, as it's intended, is a sub n equals my first term, which is 2, plus parentheses n minus 1 times the common difference as 3.5. If I treat it like we did number 2, instead of plugging in 55 first, I'm going to distribute and simplify. So 3.5 times n is 3.5n. 3.5 times -1 is -3.5. And then I'm going to add 2. So if I combine like terms, I have 3.5n. And 2 plus -3.5 is -1.5. Now that I've simplified, now I can plug in 55. So I plug in 55 in for n. So 55 times 3.5 and then subtract 1.5. So my 55th term is 191. Let's do that 2 more times with the 2 different ways. So number 5, they want the 60th term. The common difference, if from -7 to -1 is adding 6. From -1 to 5 is also adding 6. From 5 to 11 is adding 6. I know that that is my common difference. My first term is -7. So if we write the explicit formula, it is first term, which is -7, plus n minus 1 in parentheses times the common difference, which is 6. Then I'm going to treat it like I did the very first one, which means I'm not going to distribute. I'm just going to plug in 60 in for n. So when I plug in 60 in for n, okay, I do PEMDAS. So 60 minus 1 is 59. 59 times 6, and then add -7. So the 60th term is 347. Let's do one more like the second type we saw. So it involves decimals. If you have trouble figuring out what the common difference is from number to number, the trick is you take your second term and subtract your first term. So for instance here, 172.3 minus 189.6 gives me a common difference of -17.3. That means I'm subtracting by 17.3 every time. And I can check it by 172.3 minus 17.3. And that's how I get 155, so it's correct. So that's just a trick. If you don't know how to find the common difference, do the second term minus the first, not the first minus the second, so be careful. I know my first term is 189.6. So if I set up the explicit formula, A sub n equals the first term, which I know is 189.6, and then plus n minus 1 times the common difference of negative 17.3. Again, just to show you both ways, I'm going to distribute. So negative 17.3 times n is negative 17.3 times n, plus 17.3 times negative 1. And then I'm going to add 189.6. So if I combine like terms, I have negative 17.3n. I add 189.6 plus 17.3, which is 206.9. Now that I've simplified it, I'm going to substitute 33 in for n. So negative 17.3 times 33, and then plus 206.9. So the 33rd term is negative 364 for there, okay? So some ways we've seen it written, of course, this is just the same thing, more practice. So, I mean, if that's enough practice, you can stop watching, but the video will continue. So number 7, write the rule for the nth term, then find the 22nd term, So my common difference is the pattern. So 7 plus 6 is 13, 13 plus 6 is 19, 19 plus 6 is 25. So I know my common difference is positive 6. The first term I know is 7. So if I set up the explicit formula, I have a sub n equals the first term, which is 7, plus n minus 1 times the common difference, which is 6. And then I'm going to treat it like we did the very first one, so I'm not going to distribute. I can leave it like that. I want to find the 22nd term, so I'm going to put 22 in for n. 22 minus 1 is 21. 21 times 6, and then add 7. So the 22nd term is 133. Number 8, write the rule for the nth term, then find the 19th. So my common difference from 30 to 24 is subtracting 4, 26 to 22 is subtracting 4, and 22 to 18 is subtracting 4. So my common difference is negative 4. The first term I know is 30. So if we set up the explicit formula, it is a sub n equals the first term, which is 30, plus n minus 1 times the common difference, which is negative 4. And then I'm going to treat it like the other type. I'm going to distribute. So negative 4 times n is negative 4n. Negative 4 times negative 1 is adding 4. And then I'm going to add this 30 to the front. When I combine like terms, a sub n equals negative 4n plus 34. Now I'm going to plug in 19. So 19 times negative 4 plus 34 is negative 42. Last one of a basic one. So number 9, write the rule for the nth term, then find the 40th term. So from negative 11 to negative 8, I'm adding 3. From negative 8 to negative 5, I'm also adding 3. And negative 5 to negative 2, I'm adding 3. So be careful with negatives. The first term I know is negative 11. We're going to set up the explicit. So it's a sub n equals the first term, which is negative 11, plus n minus 1 times the common difference, which is 3. Just like the last, I'm not going to distribute because we just did that. All we have to do is plug in 40. So 40 minus 1 is 39. 39 times 3 plus negative 11 is 106. So the 40th term is 106. To put it into context in a word problem, let's say you visit the Grand Canyon and drop a penny off the edge of the cliff. The distance the penny will fall is 16 feet for the first second. So the first term is 16. The second term is 48, and the third term is 80. Write the formula in the explicit formula for the sequence. So a sub n equals the first term, which is 16, plus the n minus 1 times the common difference from 16 to 48 and 48 to 80. 48 minus 16 is adding 32. So that's the explicit formula, but they want to know how far the penny will travel after 30 or 20 seconds. So I can distribute and solve, or we can just plug in 20. So 20 minus 1 is 19. 19 times 32 plus 16. So it will fall 624 feet by the time it hits 20 seconds. So explicit formula definitely comes in handy when you're thinking about terms larger than 10 per se.